I have to admit, when I first started prepping for today's deep dive, I hit a wall.
Oh, yeah.
We're looking at the Kramer CLS-AOCH-60-262. It's an HDMI cable. But then I saw the MSRP, $1,000.
It's a number.
It's a huge number. Even on sale, it's $800. And my first thought, and I'm guessing it's yours too, listening to this, is this snake oil?
That is exactly the right first question to ask.
You know, like those gold-plated cables that promise better zeros and ones. Is this just the industrial version of that kind of voodoo?
It's a fair question, but no, this isn't about audiophile magic. The real mission here isn't to review a wire. It's to understand the physics of moving just a massive amount of data over a really long distance.
We're not talking about connecting a PlayStation to a TV 3 feet away.
Not even close. We're talking about 262 feet. That's 80 meters of uncompressed 4K video.
Right. And I know from experience, if I try to run a standard copper HDMI cable over, say, 50 feet, things get flaky.
Flaky is a good word for it. You hit the wall of attenuation. Copper has resistance, and when you push a high bandwidth signal, like 4K at 60 hertz, with full 4.4.4 chroma sampling.
And 4.4.4 is key, right? That's the full color information, no compression.
Precisely. It's the gold standard. You try to push that down 200 feet of copper, the signal just dies. You don't get a fuzzy picture. You get what's called the digital cliff.
Sparkles, drop out.
Oh, just a black screen, nothing.
So Kramer's solution here is active optical. I'm guessing that means we're using light instead of electricity?
Basically, yeah. It's a hybrid. The connector on one end converts the electrical HDMI signal into pulses of light. It shoots those pulses down fiber optic strands, and then the other end converts it back to electricity.
So light doesn't have resistance like a copper wire does.
Exactly. Which is how it handles a data rate of 18 gigabits per second without losing a single pixel. But it also solves another huge problem: interference.
Ah, right. All the other stuff on the walls.
Yeah, power lines, HVAC motors, fluorescent lights. A copper cable acts like an antenna for all that electrical noise. Fiber is just glass. It's completely immune.
Okay, that makes sense. You're paying for rock-solid signal integrity. But honestly, the feature that really sold me wasn't the fiber part. It was the physical design, the pluggable ends.
Oh, that's the game changer. If you talk to any AV installer, that's the feature that makes them light up.
Because trying to pull that big, clunky HDMI connector through a conduit in the wall is, well, it's a nightmare.
It's often impossible. The head is just too big. So what Kramer did is they put tiny micro HDMI connectors on the actual cable, and then you snap on the full-sized heads after you've pulled the cable through.
And they include something called a pull-through capsule. What's that?
It's basically a little protective helmet you clip over the micro connector. It gives you a smooth, rounded edge so it doesn't snag or get damaged while you're pulling it.
It's also surprisingly thin. The spec says 3.4 millimeters in diameter.
Yeah, it's thinner than a lot of phone charging cables, and it has a tiny bending radius of just 6 millimeters. A long copper cable is thick and stiff as a board. This stuff is more like string.
There's a safety note here, too. Low smoke and halogen free. Is that just standard jargon?
No, that's a really big deal. That's a building code requirement for running cables in plenums, the space above a ceiling, for instance. In a fire, you need materials that won't release toxic gas. Your average consumer cable would never pass that test.
So it fits in the wall, it's safe, and the signal gets there perfectly. So let's talk about what that signal can actually carry. We said 4K at 60 hertz. What about things like HDR?
Yep, it supports HDR high dynamic range, and crucially, it supports HDCP 2.2.
The copy protection.
The handshake.
The dreaded handshake, which is so notorious for failing over long, cheap cables. If that connection drops, your screen goes black, period. This keeps that link solid. And audio.
It's just a transparent pipe. Dolby Digital True HD, DTS-HD Master Audio. Whatever you feed into it comes out the other end. And the connectors are 24K gold-plated, so you're not going to get corrosion 5 years down the road, which is another common failure point.
So to bring it all back to that $1,000 price tag, this is not something you buy to get a better picture for your gaming console.
No, absolutely not. You buy this because you're running a signal from a server room to a projector in a massive auditorium or to a digital sign 200 feet away, and failure is simply not an option. It's an infrastructure investment.
It's basically an insurance policy against having to rip open your drywall because a cheap cable decided to give up.
That is the perfect way to describe it.
It does make you wonder, though. As we're pushing toward 8K and whatever's beyond that, copper just seems, well, it seems like its days are numbered.
I really think we're witnessing the end of an era for high bandwidth video. We're hitting the absolute physical limits of what electricity can do over copper. We're getting to a point where the only thing fast enough to keep up with our data is light itself.